Here are 5 useful attributes in Unity. These attributes are used quite common, but I want to emphasize on the why more than the what. First up is SerializeField attribute, which is used to make the fields of private or protected variables visible in the inspector. We can do that by simply adding the attribute above or before we declare a variable like this. Essentially, serialization is the process of translating a data structure or an object into a format that can be read. For example, a file or a database. Unity translates the data into streams or a series of bytes and then converts it into YAML code. Unity has a powerful serialization library that reads this YAML code and it updates the editor accordingly. You can confirm this by opening a prefab or a scene file in a text editor, and you'll be able to see all the serialized data over here in YAML code. This here is the class. These things to the left of the colons are objects, and the things to the right are the IDs for that object. Some things to note while using this attribute is that this doesn't serialize static fields, constants, or properties. More on serialization towards the end of the video on attribute number 5. So make sure to watch until the end if you are interested. Now, why should we do this? Why can't we simply use public variables instead? Well, this is useful for protecting data. If you make variables public, they become accessible to external classes, which means any other class could potentially change this value. This may be a potential risk. This is also the case when it comes to inheritance. Since public objects are always inherited publicly by the child class, this leads to the same risks. You can avoid that by using the SerializeField attribute on the parent class, and the field would still appear on the inspector. You can still use this attribute on private variables on the parent class to serialize it, but still protect it from child classes because they cannot be accessed. Using this on protected variables would not prevent this from being accessed by a child class, but would still prevent this from being accessed by other external classes. Attribute number 2 is the range attribute. This is used to restrict a float or an integer value between two values on the editor. Using this attribute serializes the field in the inspector in the form of a slider. Now, it has two arguments, and they are the minimum and maximum values for that slider. For this example, I will give 0f and 100f, save it, and you can see that the slider appears. And now you can assign the value by dragging the slider. Just keep in mind, this way you're calling the range attribute constructor. This can be handy if you're working in a team, and this way you can force your game designer to choose a value between min and max. Also, this attribute only works in the editor when the game is not being run. When the game is running, the value will not get clamped and can go below or above the set values. Attribute number 3 is the RequireComponent attribute. This attribute allows you to specify dependencies for a mono behavior and automatically adds them to a game object while adding this component. You can use it by writing it on top of the class like this. You would need to use the type of operator and specify the type for each dependency. You can also add multiple types in the same attribute by separating them with a comma. Now if we add this component to a game object, it will automatically add all the dependencies. Why is this useful, you may ask? This can be useful to avoid errors. Allow me to elaborate. Suppose you have a class called player control. You also have a class called enemy control. And you can have a common dependency called character data. Now, whenever you or your game designer wanted to create a new enemy, you will never have to worry about adding this dependency. It will automatically get added when you add enemy control. You won't get a null reference. This is also useful when you are developing packages. Attribute number 4 is Tooltip attribute. It is used to give information on your field when a user hovers their mouse over that field in the inspector. You can add this attribute before you declare a field, and then you may pass a string as a tooltip. For this integer called number of lives, I can add a tooltip and give info to the game designer like the number of lives left for the player set to -1 for infinite lives. Do you get what I mean? If used effectively, it brings about clarity. And over the long course of developing a project, you may need a friendly reminder once in a while. As you can see, this would be extremely useful while creating packages or working in a team. This gives the user an idea of what this field does when it comes to the grand scheme of the multiverse. Attribute number 5, the final attribute for today, is Serializable attribute. This attribute tells Unity that this class or struct can be serialized. You need to be using system namespace to access this attribute. Or you can write it as system.serializable instead. If we want to know why this attribute is important, we need to know some things about serialization in Unity. By default, Unity only serializes objects that inherit from UnityEngine.Object class. If you want a custom class for other things, for example, while making an inventory system or something, you might want to serialize some of the available fields just for the sake of debugging or even assigning references. This is exactly what the serializable class does. Note, you can only serialize non-generic and non-abstract classes. The presence of this attribute makes it so that you can create non-serializable classes as well. You just don't have to use it. Serialization offers a significant overhead. So just make sure you minimize serialization as much as possible and try not to use it with large sized objects. So that's it. I would love to know your thoughts on this. I would love to hear feedback. Subscribe for more juicy Unity stuff and take care. See ya. Bye bye.